In this example, we're asked to rotate this region bounded between two curves. So we've got two curves, y equals x and y equals x squared, and we want to rotate them about the x-axis and find the volume of the resulting solid. All right, so the first thing I want to do is just draw what that looks like. So again, I'm going to just draw my y-axis, I'm going to draw my x-axis, and let's just draw, here is, say, y equals x, right? And then y equals x squared looks something like this. And they're going to intersect at 1, 1, right? Because they are equal at that point. So this point is 1, and this point is 1. So the x and the y values are both 1 where they intersect. And this is essentially the region. We're trying to take the region between these two curves and we're trying to rotate it around the x-axis. All right, so here's the x-axis. All right, so what does that look like? Well, so we're going to end up with a mirror image down here below the x-axis. So let me just kind of drop this down. And then we're going to have the y equals x reflected down here and the y equals x squared reflected down here as well. All right, so that's kind of just a mirror image of what the top region looks like. So if we rotate it, what we're going to end up with, let me see if I can draw. I'm going to draw in 3 dimensions here what the top looks like, right? So draw a little oval to represent the top. And so it kind of looks like a funnel, right? It has sort of these straight edges on the outside and the inside is curved. So now we want to figure out how to find the volume of this region. So notice it's empty in the middle, right? It's empty in the middle, and then we're just the only volume is just the sides. So let's draw what we, one disk of what this is going to look like here. So let's take a disk at this point right here. And so the outside of the disk, let me see if I can do this. Let's see. All right, okay, so there's the outside of the disk, but then it's hollow in the middle, right? So the inside of the disk the center is open. So it looks not so much like a disk as a washer, right? So we have this series of washers that we need to add up, right? So there's our disk. It's hollow in the middle, and then we'll give it some thickness just to illustrate what this looks like. Okay, so there's one disk, or in this case, a washer. And actually, this is called, sometimes it's referred to as a washer method because we've got 2 functions, and we want the region between, so the middle is kind of hollow. Okay, so the thickness is delta x, and then the thickness of the washer is basically it's basically the outside disk with the inside disk subtracted, right? We've subtracted an inside disk. So the whole the concept, or the whole idea of finding these volumes really is just a matter of taking the cross-sectional area, right, which is a kind of a washer. So the area of the washer is just essentially the area of the outside disk. So it's pi times the outer radius. Radius squared. Okay, and then we're going to subtract pi times the inner radius. Squared. Okay, and that'll give us the area of one cross section. It'll give us some thickness to give it volume, and then we'll integrate. All right, now in this case, the outer radius, so let me write this down. Outer radius is just, it's that y equals x line, right? So it's just y equals x. Okay, and then the inner radius is that inside curve. Okay, so that one is y equals x squared. Okay, and so the integral is just going to be, we're going to integrate. Okay, we're integrating in the x direction, right? And we said that this is 1, right? This is the number 1. All right, so we're going to integrate from 0 to 1 because they intersect. The two curves intersected at 1, comma 1. Integrate from 0 to 1, pi, and the outer radius is x, so we get x squared because it's pi r squared, minus pi times the inner radius squared, and we have x squared squared, which becomes x to the 4th dx. All right, that's easy enough. I'm going to pull the pi out front, and then when we integrate x squared, we get 1/3 x cubed, and we integrate x to the 4th, we get 1/5 x to the 5th. Evaluate that from 0 to 1, and then it's just a matter of plugging in the numbers. So we have pi times 1/3 minus 1/5. Okay, so that's 5/15 minus 3/15, which is 2/15. So we have 2 pi over 15. And there you go. There's our volume of that kind of funnel-shaped cone.